Simon. So today I will present our project with my group member Lau Hao Ming and Brandon Chin Wei Chong. So for the assignment one, the system is designed to address database and cloud security principles within the academic institution. So moving into the task one, traditional student record system heavily rely on physical paperwork or unprotected digital sheets. So this method are slow, prone to data entry not the same, and present major security risks. And so our primary objective with this project was to eliminate these vulnerabilities by designing a centralized web application. The core focus is to protect student privacy using a strict client-server architecture, separating our presentation interface from our underlying logical endpoint to structurally prevent unauthorized access. And the next, to implement this architecture safely, we selected a lightweight production-ready development stack. The frontend is built on by React.js and TypeScript to ensure high type safely and a responsive UI. The backend uses .js and Express.js to explicitly handle core security logic and API validation. So for the data storage, we choose an optimized SQLite database backup into distinct user credential and student directory table. This entire system run efficiently on standard infrastructure, requiring only basic hardware specification like an Intel i5 processor and 8 GB of RAM is enough. In task 2, we map out the logical operational workflow of the software across 4 distinct phases. So, firstly, when the user log in, their plain text password never touched the database. The backend securely compare it using bcrypt verification and issue and encrypted JSON web token. So, secondly, the React client capture this JWT, extract the embed user role, and dynamically load the interface on the fly, granting administrator full access while rendering element as read only for user. Thirdly, when reading record, the backend strictly ignore unvalidated raw input, fetching data with via safe parametric data queries. Finally, any data addition or structural modification are to be sanitized and instantly recorded into a chronological activity registry to build an immutable audit trail. So next we'll pass to Brandon. So thank you.
My name is Brandon Chin, and I'll be presenting for the task 3 and task 5. So task 3, we have strike threat modeling. So firstly, we have spoofing. We consider risks such as the unauthorized login attempts and stolen administrator credential, which may give unauthorized users the access to the system. For tampering, we have unauthorized modification and deletion of student records, and this may affect the data integrity of the students. Next, we have repudiations, where the users may deny the actions performed, which will reduce the accountability. Next, we have information disclosure, where sensitive student records may be exposed to the unauthorized users. We also consider the SQL injection risk, where malicious inputs may expose the database information. For denial of service, DOS, where excessive requests may overload the system and affect the availability of the system. Finally, for elevation of privilege, the viewer users may attempt to gain the administration access, which will compromise the security of the system. So next is the threat risk assessment metrics. So these are just some of the main trends. There are more in the report, but we have stolen administration credential, unauthorized record deletion, SQL injection exposure, and system overloading or DOS. All of it is mostly medium risk. For example, the stolen administration credential, where you could give full access to the student records, and then the SQL injection can expose the database information. And for the denying of actions performed by users, which is a low risk to medium risk, because we have the activity logs that can provide accountability and tracking of the users' actions. So overall, the risk factor is a medium system risk profile, which is 5.5, which is 6. So the risks are present but reduced through some of the security controls.
Hi, my name is Ming. Today we'll talk about Tax 4 PDPA 2010 personal compliance. And PDPA 2010 personals have been categorized several roles from our project, which is system owner, backend developers, data admin, database admin, register users, and enroll students. And let's talk about system owners. Their legal class is data user and core controllers. Their responsibility is determine scope, legitimacy, processing methods, and target authorization boundaries. For the back-end developers, which is data processor, program, mechanical safety parameters, JWT, bcrypt hashing, and parameter mapping. For the database admin, they are data processor that maintain database schema, and update relational index safely. For the register user, which is data operator, they're processing daily system operations within the interface matching assigned role. And last, for the enrolled students, they are data subject, their legitimate source of identity, data handled within systemic structures. Let's talk about the data life cycles, governance, and penalty. So life cycles compliance metrics, slide 53, is 4 stage. First is the collection stage is privacy notice and account creation concern alert. Storage stage is sorted bcrypt hash plus active role-based access control limitations. For the processing stage is sanitization, filtering, and parameter checking statements. For disposal, permanent storage, deletion, with SAT, removal part. For the penalty for violating Act 270, Site 57, general concern breach, Section 6, up to 500,000 fine or 3 years imprisonment maximum penalty limit. For the security standard failure, Section 9, up to 300,000 fine for non-compliant storage or disposal method. The retention management mistake, Section 11, fine maxing out at 100,000 for maintaining stales are purged data. And that's all for me. Thank you.
Task 5. So for internal protection, we apply the bcrypt password hashing to secure the password. We also have audit logging to track the activities and role-based access control filtering to prevent the users from modifying the records. For external protection, the system has the JWT authentication and temporary login restrictions to prevent unauthorized access, SQL parameterized queries to reduce injection attacks, and also request rate limiting to prevent basic denial of service. So testing was conducted, and to verify these protections, the result showed that unauthorized access, SQL injection attempts, invalid login attempts, and excessive requests were restricted by the security measures. So that's it for me.
Okay, so now I will present about the demo part. So here's our application login page. So here's the username and password here. So it will encrypt it and the admin access and will access here. So the username here, if we input the incorrect username, it will unable to log in. So it will show the invalid credential. So if I input find time or find time incorrect, it will show too many login attempts. We need to wait for like 10 seconds of the cooldown. So okay, so here's the admin dashboard. Here's the student and the student email, the details of the course, the GPA and ID here, and here's the activity log. Okay, so you also can search for student, like maybe the John. So we show here. Okay, we also can add student here, maybe like uh okay, so the official email. We can use this one, and you can choose for the courses. Okay, so the GPA here, if one for all, it will show the invalid, and don't need to be 4.0 below, so maybe 3.9. Okay, so step record. So here we will have the new record here, and the activity row, activity log. We also show the action, uh, what the admin done by. So created student. Okay, so we also can delete the student. We so when click on the button here to show a confirmation uh, pop up and confirm, then it will delete it. So next is the viewer dashboard. Uh, okay, so here is the viewer dashboard. It also same as the admin dashboard, but just don't have the activity log function here. Okay, Okay, so thank you. That's all for my presentation.